Hello again, my name is Mr. Brash. This over here is Mr. Squirrel. He likes to join me on my lessons, and I'm going to be going over part 2 of solving quadratic equations. You might want to check out my first part before you check out this one. We're going to be going over solving quadratic equations by factoring. And I always like to start when I can with some sort of recall. So just really quickly, I'm going to go over this idea of how do we multiply to get 0. So I've got this equation on the left. We'll do it again on the right. I've got an a times a b. How do I get 0 out of this? What are the possible values for a and b? Well, in order for this to be true, you have to understand that multiplying by 0 is what creates 0. Either, and this is where we have two potential solutions, either my a is 0. We don't know what it is. It could be 0, but it could be anything. It could be negative 85. And if it's 0 and we multiply by b, doesn't really matter what b is, we'll get 0. But it might not be 0, could be another number. And if it's another number, maybe the b is 0, and that's what's causing this multiplication to be 0. And so when we write out our answer, we would typically say a equals 0, and you can use the word or. You could also just put a comma, b equals 0. So we have two potential solutions here. Now, of course, there's all sorts of other options as to what a and b can be, the value of those variables. But as long as one of them is 0, we get our answer of 0. And so something similar happens when we have this factored form equation, what you see here on the right. So we might be asked to solve for the value of x. Essentially, I've got an a here, which is my x plus 9, and a b here, which is a 3x minus 7. If x plus 9 is my a, then I can say x plus 9 is 0. Or, and I can use a comma for that, doesn't matter, 3x minus 7 is 0, just like my a was 0 or my b was 0. We were asked to solve for x. Let's do that by adding or subtracting on each side. So I'm going to subtract 9 on both sides, so I get x is negative 9. Here I'm going to add my 7 on both sides. Ultimately, that's subtracting a negative 7, but I'm not going to get into that. And I'll divide by the 3, and so we get a fraction of 7/3. What does that mean? Well, it means that if I put negative 9 in as the value of x, I get 0 in this bracket, which makes this statement true. However, if I put 7/3 into x, the second bracket becomes 0, which makes this statement true. What I'm going to be talking about today is creating this factored form when we don't have it. What can we do when we have this standard form in order to solve by factoring? All right, here I have a graph of a quadratic. This is the quadratic x squared minus 12x plus 20. You know it really well, don't you? No, of course you don't. But what I've done is I've just kind of zoomed in on it, and we can see this parabola goes down below the x-axis. So here would be this would be our x-axis, and this would be my y-axis. And it crosses the x-axis in two spots, here and here. Those are what we would call x-intercepts. And you've probably heard that before. Well, the x-intercepts are going to start taking on a new name. The x-intercepts are going to start taking on the name zeros. And that's just a way of saying that the y value is 0. The y value is 0 at those locations, because we're going to really start to care about what the y value is at different locations on a graph. I might ask for different locations. I might ask, what are the x values at a y of 5? Or what are the y values at an x of 1? And looking at a graph, sometimes it's hard to get that value. If I'll just use my y value of 5 as an example, well, that's here. We'd have to sort of interpolate what that is on our graph at some point. It's really hard to tell. What really helps us is the equation. So I'm going to take this equation and I'm going to ask two different questions. I'm going to ask, when is this graph equal to 0, which on this particular graph is pretty easy to tell. It's at 2 and at 10, but we're going to prove that algebraically. And then I'm also going to ask, when is this graph equal to 9? Let's take a look at that right now. So when does this quadratic that I just had up above, and this is the equation right here, x squared minus 12x plus 20, when is that 0? And then again, when is it equal to 9? Well, it's not in a factored form. It's not in some sort of way that I can magically discover what is equal to 0, what my solutions are. And there's no real easy way to solve it as it stands right now. We're going to use our previous skills. If you don't know how to factor a quadratic, if you don't know how to do a trinomial, so this is a monic trinomial, trinomial, what that means is the a value is a 1. The item on the x squared, trinomial, I'm having a hard time writing that, is a 1. There are ways to factor when it's not a 1, and you should have those skills as well. So I've got a whole playlist on factoring. You should totally check that out, or check it out on Khan Academy or something like that. In future videos, I'm going to show a trick, a really cool way to get those solutions really, really fast. There's a professor, I believe he's based in Pittsburgh, who came up with a new way of coming up with the zeros really quickly. I can link to it in the description and maybe somewhere up in the top corner here. All right, we're going to do the product and sum. So we're looking for two numbers that add to make -12, and when they multiply, they gave me 20. So the factors of 20 is where we're going to start. Well, 1 and 20, 1 and 20, they're not going to work. Let's say 2 and 10, that's a potential solution. 4 and 5, not going to be a solution. So let's focus on the 2 and the 10, which of course from the graph we saw that it is definitely 2 and 10. How do we get them to add to be -12? Multiply to a +20? Well, they both have to be negative. And so from previous skills of factoring and that really quick example I just gave, we can write this trinomial out as this factored form scenario. But what you're seeing is an x minus 2 and an x minus 10. What we know from the graph is that the zeros, or the y-intercepts, are at +2 and +10. What that means is they're already solved on the graph. We think that x minus 2 might be the thing that made this equation equal to 0, or it could be the x minus 10 that made this trinomial or this quadratic equal to 0. So now we solve. X is equal to 2 or x is equal to 10. +2 and +10, just like we saw on the graph. And those are our zeros. So you might be asked to list them. You might be asked to tell you to state what the x-intercepts are. They're all the same thing, just different ways of saying it. So my zeros are 2 and 10. Also could be written as a comma-separated list. So that's when the graph is equal to 0. But when is my graph equal to 9? So in this case, I'm not solving for what we call the zeros. I'm actually solving for something called the roots. And don't really worry too much about why they're called roots. Basically, it's just not equal to 0. It's equal to a different number. What we're going to do is we're going to simplify this equation by bringing 9 over to the left-hand side so that our equation is actually equal to 0. It's almost like we're cheating. Now, in order to do that, what I'm going to do to both sides of this equation is I'm going to subtract 9. Now, what would that do to our graph? What would that do to the way our graph looks? Well, I'm going to show you the graph right now, and if you're looking on a small screen or up close to your eyes, something like that, the background's about to change to a white background, so just hold on here. So here I am in Desmos, and this is the graph that I've been dealing with, and we can see my zeros at 2 and again at 10. But next up, I've been asked to discover when is my graph actually equal to 9. So this horizontal line here is 9. And I've got it just intersecting my parabola here and here. What we just did in my work was we subtracted 9 on both sides. Well, if we're going to subtract 9 from our graph, watch what happens. So I've subtracted 1, subtracted 2, 3, 4, 5, 6, and now I've subtracted 9. Down, you can see that my parabola, which the original parabola is the orange one, traveled downwards because I subtracted 9. That brings those two intersections down to the x-axis. So we're kind of finding zeros. We can't call them zeros because they're not. They're up here. But we call them roots because we can bring them back down to the ground and solve for them at these two locations. Now, because it's a graph, I can see that they're at 1 and at 11, but let's prove that algebraically. All right, we're back. We've subtracted 9 on both sides. Let's factor this to make sure that we can get 1 and 9. So we need two numbers that multiply to make 11 and add to make -12. So the only two numbers that multiply to 11 are 1 and 11 because it's a prime number. So we already know the answers from the graph, and we just verified that it's 1 and 11. Now, in order to add to -12, it's got to be -1 and -11. And of course, you could expand that back out. There's different ways to check your factoring and all of that. So my two solutions are that x minus 1 should be equal to 0, because don't forget, we're not equal to 9 anymore. We brought that over. Or x minus 11 equals 0. And we'll just quickly solve for x in both cases. Now, if it's this obvious to you that those are the solutions, you don't really have to go through the problem of solving it. You really only need to do that when you come across something quite difficult like this, where you think you need to do the algebra to solve it for yourself. You might get a fraction, something like that. But when you're in a scenario like this, you could just say the zeros are 1 and 11. Okay, one final example here, just to make sure we know what we're doing and sort of covering all our bases here. I've got this quadratic y equals all of this junk, and we've been asked to solve for the zeros of this quadratic. It's not already equal to 0, it says y equals. This could be written as state the solutions, state the x-intercepts, what are the zeros, different ways to say it. In order to solve for the zeros, I need to make the equation equal to 0. So instead of a y, I put a 0. Of course, this could be on the left or the right of your equal sign. It really doesn't matter. In all of my previous examples, my a value was a 1. Let's take a look at how to factor something like this, especially since I've got a negative as my a value. If you know anything about factoring, especially my videos, you'll know that I always stress look for a GCF first. So I see a GCF of 2, and I'm going to take that negative 2 with it. So I'm just going to factor out a negative 2. That's going to leave me with x squared plus 6 now, and minus 55. So we've got x squared plus 6x minus 55. What I can do is I can either ignore this negative 2 and just leave it out there and continue to factor the rest of it, which is what I'm going to do, or I can actually divide both sides by negative 2. And what do you know what happens when you divide 0 by anything? It just disappears. It becomes nothing. So realistically speaking, I could just say 0 equals this trinomial. I'm not going to do that. I'll leave it there because the negative 2 did exist. But now I'm going to factor this trinomial. You do that however it is you want to do that. We're going to look for two numbers that multiply to 55, specifically negative 55, and add to a positive 6. Now, that's a huge hint that one of them is positive and one of them is negative. Can you figure out what they are? So you might have gone through the trouble of figuring it out, trial and error, and different ways to do it. And I'll be creating a video at some point on really quick way to do it, a really nice, fun, and quick and dirty math trick to do this. But the different factors that do this for us are going to be 5 and 11. And the 11 has to be positive, and the 5 has to be negative in order to match my two different terms here. What does that mean? It means that my solutions, or my x-intercepts, are x equals negative 11, because x plus 11 would be equal to 0, and I would solve that. And x equals positive 5, because x minus 5 is equal to 0, and I would have solved for that. And those are my two zeros of this quadratic scenario. So we're combining factoring now with solving for zeros of a quadratic. We're not really going to be graphing, because we all know that graphing is kind of gross, but what we're doing is we're finding these really important points on a graph using the algebra. Now you might be wondering why. Why are we doing that? That might become a little bit more obvious later on as you learn how and why we're finding zeros. I'll have other videos on that as well. But ultimately, we're solving problems. We're sort of learning and expanding our minds here. As always, feel free to leave a comment, like the video if you liked it. If you didn't like the video, don't click that thumb down button. Leave a comment, tell me how to improve the video. And if you're so inclined, subscribe to my channel. This is Mr. Squirrel. I'm Mr. Brash. He approves this video, and I'm out of here. Have a great day.